All right, I can see that it's 2 minutes past. I know that there's still a few people joining. We'll get going, we'll kick off, and we are doing something differently this time. So also very welcome to give us feedback like how it works. So we've heard a lot of feedback about you would like to get more hands-on experience, and we are aiming to accommodate that by testing different ways of doing so. So at the end of the session, you will have the opportunity, if you have time, to do practice sessions. So basically doing the things that we talk about in practice. We have those self-driven labs for you, and those are available for 72 hours after this session. So those of you who have the opportunity, please stay here and you will get the access first because you're here as a live audience. So hang on. So good morning, everybody. Today is the first in the data engineering series that is about the purpose-built data services. And like mentioned, this is a series of sessions, and this is around the data domain that we have been talking about during the kickoff. And I think everybody knows me. So hey, everybody, my name is Ursula, and I actually have a speaker with me today and really happy to have him here. So Adamu, would you introduce yourself?
Hey, my name is Adamu Haruna, and I'm a senior solution architect in AWS based out in Finland here, and I'm actually Ursula's teammate. So yeah, so that's me. And then I've been kind of working with AWS for a little bit over 4 years now. So yeah, always kind of involved in the learning and sharing kind of area, and actually a lot of the time with Ursula as well.
Thank you for doing this with me, and really happy that you're here. So hey, before we get going, I would like to do a shout out to our affinity groups and specifically Clamazon for funding us. So we are doing these trainings also supported by our global teams and affinity groups, and that is so valuable, that help that we are getting, because we wouldn't be here otherwise. Couple of things that we could go through. So kind of the layout, what we are doing. So it's always a good idea to ask yourself, what are we doing here? Why are we here? And who are we? So the question, why are we here, can vary quite a bit depending on your start level. So you might be starting your career, you might be in the university, you might be in high school still. So the reason why you're here might be about you want to try out cool things and try how tech works. That's absolutely fine. So it doesn't mean that everybody has to get all their certifications and let's say study points for university. So the reason can vary. So don't worry about it. I know that there are different start levels. So the other question is that who are we? So we have been collecting a bit of data, and what we can see from the collected data is the fact that there are people who are beginners, there are people who have done a bit in this area already in the data engineering, and then there are people who are kind of intermediate and maybe even have their first job role. That's also okay. So hey, there's a lot of you out there, and happy to support you all. Also really appreciate the fact that you're supporting each other. So any questions, support that you need, let us know. So the feedback helps us grow the sessions better. Then the question is, where are we going? So we could target just the certification path. So we could just look at how to get to a certification, but that's not the point really. So we are actually aiming to learn the things that we talk about. So the certification is a good goal if you want to kind of test at the end that did I understand all the concepts. But if you just want to take part in part of the domains, let's say data domain, that's absolutely fine. You can do so. Everything will be recorded, so you will have access to recordings. All the slide decks will be available for you to study through if you want to check through them later on. Those of you who are aiming for the certification, like mentioned, the expectation is that you have a fundamental understanding, either cloud practitioner or something similar, that you understand the concepts of what is a region, what is a VPC, or basically you can study that in parallel, but that's a bit harder path to do. The certification we are aiming for and what we are now funding this time will be the data engineer associate. So it's a bit harder than the practitioner, but it won't be the pro level. Certification holds 4 main areas. There's the how to move the data, transform the data. There will be the actual data store management, operations and support, and security and governance. And like I said, everybody's journey looks different. So you don't have to think that if somebody's going for the certification, you have to pick and choose what you want to do. So it's absolutely up to you, and happy to support you with that. So that being said, I would like to hand over to Adamu. So let me actually stop sharing, and I will be taking care of the chat. So any questions you have, drop them in the chat. I will answer them. If there's something that I can't answer, or I see that there's a lot of the same questions happening, I might stop Adamu and ask you, hey, what do you think? Could we talk about this concept a bit more? So let's do it also a bit interactively. Any links and things will be in the chat. We will share also afterwards the links so that they will be available for you specifically when you're doing the practice stuff with the training environments. So, yes.
Yeah, hey, hi everyone. Nice to meet you and glad you could join us for this session. So today, the session is going to be about purpose-built databases. So what I'm trying to do, I'm going to walk you through the different purpose-built databases and why we do have those purpose-built databases. And what I would try to do in this is to really give you the fundamentals of why you need a purpose-built database and in which use case do you use which category. And then we try to kind of understand the core, and then probably we might not cover all the different areas of the purpose-built database, but this is really kind of good to build on it. But what do you call it? But the topic here, like Ursula mentioned, the theme here is data engineering. So before we go to the purpose data build, I just want to kind of highlight what you'll be kind of dealing with, or you'll be kind of getting familiar with this data engineering kind of landscape. You know, within the AWS, the data kind of landscape is like you always kind of have the data lake, scalable data lake, which is the S3. And then around the S3, there are multiple services based on what is the job, what is the task that you are going to execute now will require. You have different data services, like you have analytics, like you can use Redshift for long-term sustained analytics, or you can use Athena for ad hoc analytics, right? And then this S3 is like kind of a source of truth, the main data lake, but you can have direct ingestion into S3. But the other things you will notice also within the landscape here is that there is a lot of data movement from the S3 to the S3, and there's a lot of data sources within the landscape that would kind of, that you have to work with, which is like there are relational databases, there are no SQL databases, and there are purpose-built databases like part of NoSQL, like search, like graph databases. And as a data engineer, you'll be working with all these things based on the task execution. And sometimes you move data from one system to another system. And we have service like AWS Glue, which is a data kind of integration service that you can leverage. And the other thing you realize that not everybody you want to give the same access or permission to access different data sets, you know. And when I mean everybody, I mean including the system, you might need to, there should be a governance. So you have something like lake formation that we could use for governance to decide or access and permission boundary, who has this access and what the person can do with that data set that is being given access. So the access and permission. So we have all multiple services that you will be getting familiar with during this journey. But for today, we would like to focus on the data sources like purpose-built database as one of the data sources that you encounter, either moving to S3 or moving some data set to those purpose database. because you want to execute certain specific functionality. And the other thing also is that we will dive into why you have those purpose-built databases and when to use them. So with that said, I'll move on to kind of start with the database. So when we say database, we all know the relational database. We all know this RDBS. It's been there since the 50s, 60s. And traditionally, what you see is that one single box database, you use it, we've been using it for every kind of workload, enterprise workload, application function, you have one single database. And whether you are doing order processing, whether you are doing analytics, reporting, inventory, it doesn't matter the enterprise or it doesn't matter the workload or functionality, we use the same database to kind of handle those kind of workload. And usually it's a monolith, it's one big box with everything in it, and we are either running it on a data center or we are running it on some on-premise somewhere in the cloud. But the problem with this is that you tend to have problem of scaling limitation, because usually when you start with your application, your users, your application is so small, your growth is so small, you can handle it, but you grow, and then you don't know how much you are going to grow. So you have to think about forecasting, scale, you have to provision a huge resources. If you provision, and then you have to deal with the costs and the licensing. And the thing with this kind of database is that it's a one big box. Even if you provision a huge CPU memory kind of data instance, at the point you hit that peak, you have nowhere to go. You have to buy a bigger box, and there is always a limit that you can hit. And then you have to think about horizontal scaling, adding more boxes, and it's difficult with this kind of a relational database because you have to handle the complexity of joining those different database, getting those data from different data and joining them at the application layer. So this is one thing. Scaling is quite difficult. And then the challenges you have is that what about if something happened to the database that you are using? How do you keep it online? How do you develop a high availability architecture so that when your primary database goes offline, the secondary one kicks on? It kicks it on, and then you still have online, and you still kind of serving your users. And that's another architecture kind of complexity that you have to deal with. And then there is kind of a limit on different data centers that you can kind of provision a database as a secondary database. And when you do a security update, mostly it will go, you have some downtime. So that means these challenges of availability, you have to struggle with it, you have to deal with it, and it's a kind of be a bottleneck. And with everything, it needs operations, it needs maintenance, it needs monitoring, and it needs update. And with database, there's high kind of threshold workload on maintaining the database. You need to kind of configure, you need to provision the database, you need to kind of do patching, fine tuning, upgrade. All these operational issues, you need to be continuously hardware, software maintenance, and it needs to be done continuously, and it's a heavy load. So the challenges comes with, if you are running your database, you want to improve your database. So what AWS is providing or decide to do is to provide you a managed database, a fully managed database. I'm not going to go into details of all these things, but the idea is that all this heavy lifting that you do just to keep the database on, it will be taken on by AWS. So if you look on the left side, if you are running your self-managed database, these are the sort of activities, or these are the sort of work you need to do to maintain the database. And most of it is just by keeping the database on. And it's a specialized areas. You need a specialized engineers, data DBA, you need resources to put in there. But for you, what is kind of most vulnerable is your application workload you want to run. How do you design your schema? How do you construct your schema? And how do you optimize your schema? That is what is really the core to application developers, because that is what is adding value to the application. The rest is about keeping it on. And fully managed service in AWS takes the rest, the heavy lifting, and then the automatic kind of failover, the backup, the isolation, this is AWS manage that for you. And then you don't have to deal with and when you do your lab, you can see that all you need to do is just start up the database, select your instance, and then there you go. I mean, AWS manages the rest for you. So this is the idea of moving from a kind of self-manage and then leaving the workload for AWS to manage the administrative workload. So we have multiple, we have portfolio of fully managed database offering for you. And then most of them are really kind of your own commercial database like Oracle, SQL Server being managed by the AWS. So what that means is that you don't need to change any skill set. You don't need to re-architect your application. You can just lift and shift your application to AWS RDS for this relational database like Oracle, SQL Server. And then the open, if you are running open source self-managed, you can really kind of lift and shift like MySQL and Postgres to AWS, which is AWS RDS. So what that mean is that you don't have to worry about scaling, you don't have to worry about provisioning, patching, and this thing. You just worry about your activities, the workload that you are running on the database, and AWS handle the rest, right? And with the NoSQL, I mean, we have database like Amazon Document DB, which is MongoDB compatibility. So you can move your MongoDB workload onto Amazon Document DB. You don't have to, again, you don't have the API, the toolset, they are the same, they are compatible. There is no really re-architecting of your application, or you move your Cassandra workload into Amazon Keyspace, or let's say you are running the open source Redis and Memcache kind of in-memory database, you can move them to AWS Elasticcache without really re-architect. So what you mean? You still leverage your same skill set, still leverage your same API and tools, but now you don't have to deal with all the complexity of the database management and the kind of database maintenance. Right, and in addition to that, we have different, it's not mentioned here, but we have different services that will help you do that lift and shift, that will help you do more. We call it database migration services. So you can help you like with the source and target, you just kind of set it up and it will move and migrate those database for you to use. But now that is the one thing about moving from self-managed to fully managed and then maintaining your skills, or if you want to leverage innovation from AWS, you can also move to Aurora. Aurora, which is the AWS version of the open source MySQL Postgres engine, to leverage kind of the cloud native kind of functionalities that come with Aurora innovation. Right. So now we talked a little bit about moving from self-managed to fully managed and what that entails and what you get out of it and how that kind of focus or gives you attention to focus on your value-adding service, which is how to build your application, how to design your schema, how to kind of construct your queries and optimize your queries, right? So now I want to shift your attention to another trend that is kind of changing the landscape. That is why purpose-built database is becoming very, I would say popular, but very kind of from just nice to have and must to have. If you look at modern application right now, like if you look at e-commerce, social media, streaming, all these kind of different workload, that the characteristics of modern application has changed completely because these are applications that require very high performance and the scale is really to a level that, I mean, you wouldn't imagine 10, 20 years ago. And then the requirement of availability, you want to be online, the application should be online all the time, regardless. It's also like a huge kind of dimension of a modern application. For example, in a typical application, you have millions of users, then the data volume, terabytes, petabytes, and growing, and it's usually not application in your area, it's a global thing, and the performance, you are looking at micro latency, and in some cases, even really single-digit microseconds, you know. And then the request, you have people requesting at a rate like millions per second, different access point, you know. And there are peak times where you need to provide all the resources to kind of manage the workload, and there are times that are quiet. And then there are also the interaction with your application with other systems in the modern world. Like some people want to integrate your application, or you want to integrate some people's application to your application. There's this concept of API. So that itself is a trend that is really changing the way we see web application architecture. So like with this kind of requirement, you cannot really have a monolith kind of architecture to meet the variation of the workload, to meet the scale of the workload, to meet the performance requirement of the workload. So this three-tier web application that we traditionally know, and it's been served as good, and in some cases it's to serve as still good. I mean, you see that people are moving from that to really a microservices architecture and a decoupled architecture. What do I mean by that? You're moving the architecture to architecture where within an application, you have different functions or services that are unique on their own. They live on their own, they function on their own, they are built by a different team, and they themselves have a different characteristics that they serve. And how you see that an application is by pulling all these different applications together to realize your single kind of unified application. And why is that? It's because this allows the compute to scale. This allows the storage to scale independently. And this allows different features of the application to scale based on the demand and the requirement that the final presentation layer kind of the consumption requires on the application, so that you'll be able to provide this requirement for the modern applications. Right. I will not go into this, but this is what kind of when I work as CTO of Amazon was saying that from that pressure of skill, performance, and the different kind of evolution of different functionality of service of an application, one size doesn't fit all database kind of code came about, right? Like this happening because before every workload, every application, the data model is relational, right? So you end up modeling your application based on your data model, but it should be the other way around. You look at your application, what is the requirement of my application? What is the characteristics of my application? What is the data model that will support my application? How do I store data? How do I manage data? How do I retrieve data? How do I access data? And with that, then you go back with, oh, what kind of database will meet this requirement? And that is how it should be, rather than I have relational database. How do I model my application to fit relational database? So with this, what we realize that every kind of application or every service have a different and needs the right tool to support it. I mean, just to give you an example of how this illustrate this example to you, I will use this application. So this is a phone application, right? It's an application that you can use to buy TV, right? But if you look at the user interface of application, you can see already different UI components of that user interface have different workload, unique workload, and different characteristics for the same application, right? So you have the flat screen, you have the search. You need to be able to search quickly and fast. That means you need to index, optimize the index, and you need to run through. And this kind of application or this kind of service, you need really index optimized storage to support it, so that you can quickly go around and this you can use Amazon Open Search for that specific purpose, and it's designed for that. And if you look at the customer views, it's key value. You know, you have the customer in the review, and you need the database that will that you can store the way you want to retrieve it. You have your key, you get your value. And this is like Dynamo, which is built, designed for key value kind of a database, kind of a model, right? And then when you come to the other processes, add card. So this is a place where you want to, like, you don't want to order and then the final ordering, the product is not there. Or you don't want to start paying and then you realize that there's something hiccup and then you've paid them, but you don't have the product confirmed. So this is a kind of a application that requires what? Transactional integrity. You know, once you log the transaction, there should be like, I mean, it should be logged and it should be consistent there. So you have transactional integrity, both in terms of inventory and in terms of financial accounting. So relational database is purposely designed and serve that purpose well because of the ACID kind of property of relational database. And then when you look at the recommendation, I mean, you see, this is really like a relation, where people who buy this, or it's about relation between the users, the product, and then the components of the product. So this is a graph database. It's a database that deals with connected data, relation data, interconnected. And then that kind of database, you need a graph database, which is purposely built to build this graph for you. So you can see within one application, you are using multiple databases and you are able to serve those applications with this database. Yeah, so, and this kind of emphasize the purpose data build that we are going to talk about now. So I mentioned some of these databases, but I want to take a few minutes to run through because maybe we might not get to the end and talk all about all of them, but just run through this purpose-built database and why they are built for that. So as we go along, I'm trying to give you kind of the foundation that, I mean, you really look at your application and categorize and then come back to, hey, which database is designed specifically, purposely to meet this my application requirement. Remember, relational can do all of this if you want. It has the capability, but is there a reason not to do it? And this is what we go through. A reason that something is better serve your application, and then that's what you use. So instead of listing tens and tens of the databases, I will just go through the categories of the database. So we have the relational categories, and what are the data models of the categories? With relational databases, the models, you have referential integrity, you have ACID transaction, you have schema or write. That means you need to know your schema before you start building the database. And within your database, you need to have a requirement where you kind of have a ACID transaction where you maintain integrity of the transaction, integrity of the flow. And the referential integrity is a relational database that is a database that you can put constraints and validation within the database so that, I mean, you can meet your business or company kind of rules. So you can put that. And it's a database that you don't have to know the access pattern beforehand. It's flexible in that sense that once you start, you can use any access pattern within the schema or the column and then to retrieve your database. And we have different workload use cases that you can run for this kind of relational database. And some of the databases we offer are just below, Amazon RDS and Aurora. And then we have key value. And this is really designed for high throughput, low latencies read. You can have one item in the key value or trillion item in the key value kind of database, and they will perform the same. The performance is the same. And this is a simple kind of flat structure or a key value that you have your key and then you fetch your value. And this is a relational NoSQL kind of database that, I mean, you would go to when you don't need that complexity of the relational database, but you would need the performance, the speed of access of your data. And then this one thing about relational database, NoSQL database is they can scale, and then the scale is very important. And then you can scale without kind of thinking about how do you handle the sharding kind of issue there. And then there is a document database. So the document database is also a NoSQL. All the rest that we are going to go through are NoSQL kind of databases. And this is a database where if you look at your application that you are handling document, like a JSON document, you are uploading document, you are manipulating document, and you want to kind of find out, be able to have a flexible way of querying the different attributes of your document. Then the document DB is kind of a database for you, designed with that model that you can manipulate and the documents, like content management, like personalization. So you have different attributes, and then you can query different attributes. You can kind of move the documents in and out. We have Amazon Document DB for that. And then we have in-memory. In-memory really comes where it's also a key value. You can query by key, but we are talking about moving from milliseconds to microseconds. So you have use cases like, gaming, that you have a leaderboard, that the leaderboard is changing all the time while you are doing real-time gaming. And this requires really fast response, fast update. And this is the kind of key value in-memory kind of database that you need, because the performance and latency is very, very, the latency is very low, performance is very high there. And this is the kind of, we have the caching one and we have the persistence one. And then the caching one, usually we see how you use it. Usually you use it in addition to another primary database to increase the performance or decrease the cost of your database. And then the graph, I told you the graph mainly deals with interconnection, connected data, relation between data, relation between people, relation between data points. And that is what the graph does. So you can traverse the graph and see whether you are doing cost benefit analysis, or you are doing fraud detection, or you are doing kind of recommendation. You can see it on the graph, and the drive kind of is built for that, and kind of build the graph for you instead of you kind of trying to build the graph at the application layer. You can use a relational model for that, but you have to do many calls to the database and build many and do many joins and do many manipulation to be able to have the graph kind of format, right? So the other thing is that then we go to time series, and then I think all of you have heard about IoT, event tracking, or even stock market. This is a characteristic of a time series data. What is the characteristic of time series? The data arrives in time order and is append only. And then this data, like every second, like sensor data is coming all the time, and it's append only, and it's coming that order. So time is a critical part of it. How do you usually has a certain characteristic that the manipulation and handling of data is within time window, within time window, and you need a time series is a database that is specifically kind of designed for that. You can use relational database again, but you cannot have that time window manipulation within the relational database unless you build it on your application layer, which will be complex. We have windowing average and all these time-based analytics. You have to build it on your application, but this within the database is designed for that, and then you can use. And we have Ledger. Ledger is a database that provides you a mutable and verified history of all your changes in your application. So, for example, in the healthcare area, you have your medical journal. I mean, every changes in the kind of by compliance needs to be there, needs to be recorded, nothing needs to be cannot be changed. So immutable is that when you do a change or when you do any action on the database, it's recorded and it cannot be changed. That history will be there. Even if you delete the database, that history will be there. And then it's very verifiable by cryptography. So this is the kind of database that we use, and it's built inbuilt. And white column is really for scalable, high distributed databases, where it's also like a key value where you have flexibility in terms of it's a row, column row, but you have flexibility in terms of what kind of each row, what kind of columns you may have, or what kind of attribute you may have. And this will give you like really high throughput for the write. So I think this is kind of, I ran through the categories. So now what I'm going to do is to kind of a little bit walk through the different kind of category, and then kind of give you a little bit information about that so that you understand this kind of information. So, yep. So when we talk about relational database, we are talking about database that in the relational base it started in this 50s, 60s. So it started when storage was very expensive. So you can see that we look at first normalization, second normalization, third normalization. You are trying to optimize storage and then to store this data in there. And then you usually divide the data into so many tables. So it's table per entity. And then you have relationships between the entities that you build via established keys, like a foreign key, like primary key. And it's highly structured. You have to know the schema before you start kind of building your database. And it provides you, like, it enforces kind of integrity, it will provide you consistency, it will provide you data durability. And this is how you build a relational database. So you have all these entities and you spread the data into different tables, but and you store these tables within the database. So this, I mean, kind of have highly kind of optimize your storage. But when you are retrieving the data, you have to kind of query different tables to build the complete data going out. When you come in, you have to hop in all this data. You want to get a complete data, you have to hop in all this data, like you want to get information about a doctor from an hospital, you have to hop in, query all this data, all this table, build the view before coming out. You know what I mean? So there's a lot of compute usage that you do to get your complete data. But the storage, you spread them over different kind of tables and kind of compress them and optimize them. So this is the relational characteristics that you get. And then with that kind of characteristics, we offer multiple different databases with the relational database, and these are managed databases. We have on the open side, we have like MySQL, Postgre, kind of RDS, which is AWS managed, and the commercial engines we have Mariam, Microsoft, SQL Server, Oracle Server. What this managed service does is that, I mean, like I said earlier on, you don't need to administer the database, no provision needed. You don't need to install hardware, software to maintain the database. And we have inbuilt multi-easy. I mean, so that means you are handling the high availability part of the database that, and when there's an automatic failure, if the primary database kind of goes down, and the data replication that you can replicate the data in 5 different areas so that you can use even data replication to, offer some read scalability for yourself. You have automatic backup, and you have a snapshot. So these are all kind of handled for you. And with the instance that you select, you can scale your compute and storage with few clicks. There's no downtime here. You can just few click, scale your compute, and then this thing. And as it comes with every database or every service, is kind of secured for you. And then you have encryption at rest and in transit. So this is what you can get with. And then if you want to leverage more innovation within the cloud native innovation, you can choose also a relational-based Aurora, MySQL, Postgre engine compatible relational database from AWS. This is it gives you like high commercial grade kind of performance, availability, and scalability, but with the open source flexibility. So actually, if you look at this in the performance, is the same engines, MySQL and Postgre engine, but Aurora scales like 5 times with the throughput than the standard MySQL and 3 times than the standard Postgre. And then the durability, it has a self-healing storage, so it heals itself at the storage layer, and you have like 6 copies across 3 easy, 2 copies per easy, and it continues to back up. So there is really strong infrastructure there in terms of supporting your in terms of fault tolerant. And it's actually kind of decouple the compute and the storage. So the storage kind of scale automatically. And then the compute, depending on compute size that you select, it scales within that compute size or instance size. And you get all these things that I'm not going to mention, like provisioning, software patching, setup, and this is what Aurora gives you also additional. There are additional kind of innovation like cloning, like backtracking. We are not going to go into details, but there are more kind of special features on Aurora that you can leverage. And then furthermore, on the Aurora, we have Aurora Serverless. Serverless 1, we are moving to Serverless 2. And basically what the Aurora Serverless does is that, in the previous Aurora, you select your instance size, the compute and memory that you are thinking to run, and then it can scale within that compute memory kind of automatically. The storage scales kind of, let's say, for all practical purposes, the storage scale infinitely for all practical purposes. But the compute is like you select your computing size and you scale automatically within the computing size. With serverless, if you have a workload like a testing environment where sometimes you are busy working, sometimes it's off, or you have workload that you don't know, you can predict the traffic, it goes up and down, then serverless is a kind of a right database to in terms of Aurora to choose, because you don't need to configure anything. You just put it on, and then it scales based on your workload, and it scales down based on your your workload. So when the traffic is high, it scales. When the traffic is low, it goes back. And you don't pay when it goes idle. Like we have a very small 0.5 ACU just to warm the capacity pool. ACU is a Aurora capacity unit. That is compute plus memory. So it increased very small comparing to slowly, incrementally, based on the traffic that your workload is receiving. And when there's no traffic, it goes down almost to zero. It's 0.5 ACU, right? So here, specifically for variable workload or testing environment or whatever you think that you can't predict really how the traffic or the workload is, and you don't have to do anything here. I'm not going to mention anything, but as you go along, we can talk about Aurora Limitless, but it's a new service last year, but this is not a discussion for that. So this completes our kind of this on a relational database. It's extensive. We try to go through all of them and try to give you the basis. But now, I will shift to this kind of NoSQL. I say NoSQL because there are different kind of flavors and different versions designed specifically to meet certain characteristics of application workload, right? And before I do that, just to give you a little bit of a highlight of what is the difference here, we talk about normalized database, which is a relational database. We talk about optimizing storage, so you have different entities, you have different tables spread around, and then when you are building the query, when you are retrieving your view, you query all these tables, put them together, join, inner join, whatever, and then before you get your complete view out. We did normalize, which is NoSQL. The database is already kind of you use more space, more storage, and the database is already kind of instantiation. It's there for you to pick. There is no building of the view. It's there. That's why it's pretty fast, because you just, with one key, you just go in and then get the whole thing. You don't have to build anything on the way out. You use more storage there, but look at it this way. Storage is cheap. When RDS was, when the relational database was designed and created, storage was very expensive. That was the expensive thing in the data center. See, compute is a fixed price, or was a fixed price there. Now storage is really cheap, and compute we pay per second. So you just want to optimize, use more of the cheap resources here, which is like the storage, rather than use less compute, less of the expensive stuff. So, and then with the NoSQL, you always look at eventual consistencies rather than the strong consistency that comes with the relational database. That is, you have a schema, because you are looking at scaling and partitioning, and you are looking at so you are looking at more kind of takes time for you have to have a consistent view for all the clients, right? And then vertical versus horizontal. In the relational, you scale vertically. When you meet the maximum size of your box, you get a new box. Bigger one till you hit the biggest one, and then you have to think about horizontal scaling, which is not another easy thing to do. But with the relational, why you can scale horizontally, because it's kind of every NoSQL database need like a mandatory attribute, which we call a unique attribute. In Dynamo is called partition key. In MongoDB, called hash key, and in Keyspace is called partition key. So you need that unique attribute to be able to store the data somewhere in the box. And with that unique attribute, you can divide the data into different boxes, different storage, but you can still go to that data, immediately get the key, fetch that data. So this allows you to scale horizontally. You can put them in different boxes, shard them, split them, put them in. So long as you have the key, you can go directly to which box or which kind of container that the database and fetches It's not so in relational. Relational, when you start splitting them, then you start to look where is this table in, how do you do this joining, this is kind of complex. And then the relational is more, you are building entity relationship. So you have a table per entity and you build the relation one to many, one to one, many to one. And in NoSQL, you are looking at what is the access model, how do I access this data? What is my application way of access? So you look at it and then you model that data. So this is kind of a thing that, it's a mental thing that you need to have in mind when you are dealing with this databases. So the first category in the relational database we want to talk about is a key value use case. So what is the key value use case here? The key value use case here is, you have a key and then a value associated, so field value, right? So you have the key and then you can fetch the value that the key is assigned to. And usually this key value, the items are stored in a table, in a table or collection in a table. And then you need a partition key, as we talked about. You need a partition key because that's what you use in the physical storage to store the logical. It's hash in terms of Dynamo to store your data there, right? And now we talk about a little bit of Dynamo. One thing that is not mentioned here is about the access pattern. With the key value, you need to know your access pattern beforehand. Once you build that data model, you don't have that flexibility of relational database that, oh, I want to do ad hoc query. No, I want to query on this attribute or that attribute now. No. If you don't know your query pattern, you don't know your access pattern, then maybe relational is something that you need to link to, because that will give you the flexibility of querying the data with any different kind of attribute at a later stage. But with NoSQL, you need to know the access pattern beforehand. Hey, this is how I'm going to access the data. These are the different combination of way to access my data. And then you build your data model based on that. And then the partition, you always use the primary key to query your data. And then, for example, within like Dynamo, you have the partition key, and then you have the sort key. So if you look at the table below, you can see that I have a gamma tag, which is my partition key, type, which is a sort key. So quickly on that, the gamma tag, the partition key, is just like a container, or let's say a box. Anything with that partition key is put into that box, right? So the sort key gives you a little bit of flexibility on how to group the items in that box. For example, if I have a customer and then I have a customer purchases, let me say I'm 57 is a customer, and let's say I want to use date as a sort key. So with that, I can search for the customer purchase based on this date, or the day before that, or the day after that. I can use that sort key to do a little bit of filtering into my partition key, into that specific container that kind of has that specific partition key, right? So for example, if you look at the example here, I want to get status of Hammersmith, So I'm querying the key. I'm using the key for my query, and then I'm using the type, which is like as sort key to really fetch the status of AMA 57. And then there are different type of queries. This is a get query, and this is a get command, and then there is a query command where I can query the whole table, but I'll use some condition to fetch some specific items in the query. So in this case, I want to get the whole the partition key, the whole thing, right? There is also scan, but we are not mentioning it. It's quite expensive kind of query to do, but we are not mentioning it. But you can go into details as you want, right? So the next thing I want to talk about here is that, what is our offering in this key value kind of NoSQL database? We have Dynamo. And Dynamo is actually really a cloud-native, cloud-based key value. It scales. For all practical purposes, it scales infinitely. You can handle millions of requests per second, and it's kind of a single-digit second, right? Single-digit second in the sense that, it doesn't matter whether you have one item or trillion items, the performance is the same. Why is the performance? We talked about the partition. We talk about the key to get to the data wherever the data is, and then you can spread the data in different nodes. And it has automatic global replications. It will have a Dynamo global table that you can write from all angles, and the Dynamo should resolve itself internally. And it's also tightly integrated with AWS services. You don't need to build any server, auto scaling, and we have capacity and the on-demand mode. But with all purposes, it automatically scales. And then you can integrate into other service. You can capture change CDC, change data. You can capture data change, and then you can kind of connect it with other kind of services like analytics or search services that your other microservices can utilize. There is also an enterprise-ready side that now you can support ACID and all this kind of backups and encryption at rest that it comes with it. So this is Dynamo. And Dynamo can handle trillions of requests per day, and it can handle like millions of requests per second, 20 million up in a second. So this is how it scales. So it's basically for scale. And then we have document use case. So we talked earlier on about if your use case, if your application is like handling document, JSON-like document, field value document, but you may kind of think about, oh, this is also key value or field value pairs. No, but document handles document, collection of document, right? And it handles nested structure. Dynamo doesn't handle nested structures very well. This one handles nested structures, and it gives you the flexibility of querying any attribute within the nested structure. So for example, you have a product can have variation of different attributes. Document DB can handle it, and you want to query different attribute of the product, like here you look on the right side, I have this PD and then I have the user, but in the name is another document within the document, and then the game is another document within the document. I can query the game score. I have flexibility to query any attribute within that document. And this is the characteristics of document DB. So my application handles document, deals with document. I have a storage that stores and manages items as documents, and I have that flexibility. So this is the one that you would. So how do you query? Like you can query like what I talk. Even bonus level, you are querying. The nested document, you are querying like the child within the document, and then you are querying some attribute in that. You have that to do that, and the document can have different attributes, and the document DB can handle that for you, and it supports also transaction, right? So what kind of service do we offer on the document DB side? The document DB side, Amazon service, Amazon Document DB, and this is compatible with MongoDB. So what I want to say here a little bit, what it means in compatibility is that you can use the same drivers and tools that you use for MongoDB. You can use the same API. So basically you can move your MongoDB application on Amazon Document DB without really re-architecting, right? But what do you get in that? So this is also a managed service for you, And the document DB also decouple compute and storage, so you can scale them independently, and it scale millions per read using read replicas, right? And then what you get from also this is the high availability part. You have the multi-easy structure. When this one fails, you can go to the standby. And also the multi-C is not really about when this one fails and you can go to standby. It helps you when you want to perform really a DDL operation that can make your database go offline. You can force kind of a standby. You can force failover, do the operation, and force failover back. So there is multi-easy give you room to do a lot of things around your database, right? And then building security is there. And like I said earlier on, it's MongoDB compatible. APIs, operators, data type, API drivers, and all these things. So basically, you can run your MongoDB or you can move your MongoDB on Document DB, and then leave AWS to take care of the management of the scaling, the performance, the patching, this thing, all below there for you. AWS will do for you, and then you just focus on your application workload. Right. So before I move, I think I little bit kind of want to highlight. Okay, so we are talking about key value, we are talking about field value. They all handle some kind of document. What is really the indicators for you for MongoDB and for DynamoDB and then for DocumentDB. So for you to when you look at DynamoDB, the query pattern, you have to have well-defined query patterns before you even do design your data model, right? You have to have, I keep insisting on that. Then there might be some flexibility with the global secondary index, which is kind of limited, but the core thing is thinking about, do I know my access pattern? Is my access pattern well understood? Yes, then I will design my listen based on the data model with MongoDB. Please don't use the understanding of table per entity and the understanding of designing table or designing a data model from relational database to this kind of Dynamo. It doesn't work like that. You can build table per entity, but you are using really relational design Dynamo. Dynamo, the whole document is a collection. You put them in one, and then you need to have your access pattern. And then if you are looking for single digit millisecond, and if you are looking for infinite scalability, by all practical purpose, infinite scalability, it will scale to any kind of level that you want. And then tight integration with AWS service. And there are also a lot of rich services. So then you are looking in direction of MongoDB. But DocumentDB, you are looking for, maybe you are running MongoDB already, you self-manage or on-prem or this, and you want kind of somebody to manage it for you, and then you want to use MongoDB, that's DocumentDB. So it is MongoDB compatibility. And then what DocumentDB also has is that data model flexibility. You can do ad hoc query there. You can query any attribute. You can have any kind of any row or any kind of item can have different set of attributes. It's the same with Dynamo anyway. And then you can query the nested data, and heavy read, and it goes up to 64 terabytes. And so that, you don't have a infinite scale like this, but this is something that you can scale also on. Yeah, so then I come to in-memory. So before I go to in-memory, I just want to explain a little bit about the in-memory. This, like for application that you require extremely low latency. We are talking about moving from milliseconds to microseconds response, and then usually those kind of applications, they have bunch of requests coming to them, like thousands to millions of read and write, and you need to respond quickly. Just look at gaming. The gaming application, you are Fortnite, then you are playing thousands around the globe. You are playing the game, and your ranking is changing all the time based on your performance of the game. So we are talking about microseconds. We are talking about huge load, terabytes of data. So this database, this data is kept in memory. It's not in disks anywhere, because no disk can handle that. But if you look at the architecture below, we are talking about, you can use it in different ways. So the caching layer, what you use in memory database some of the time is that you put it in front of your primary database. This will help you reduce cost. One, this will help you speed up your application response. For example, if you put in memory a caching layer, if you look at this architecture and you have your data source, look at the relational database. You have to calculate or put together all the data from different tables to get a complete view. And if you have to read that millions per second, you do each calculation millions per second. But when you get that result and you have a key value of that result, the key search value, and you saw it in the caching layer, you don't have to do that again. You don't have to go to the relational database. When you have the key search, you just fetch the document quickly from the caching layer, which is like the in-memory database that you put in front of this relational database. And you can put in front of NoSQL database, but just to handle the caching layer for you, right? So it reduces the cost, reaching the database and doing the calculation all the time, and it will increase the speed, the response of your application tremendously. And this can scale. I'm not going to go into the caching strategy, how long the caching should live there before it's kind of deleted, and what is the cache hit, cache cache miss, and how do you strategize the TTL of the caching is for another discussion. But for this one, just know that, I mean, you put this and then you hop this in. So what do we have? We have we support both open source engines for memory in-memory database. So the Redis and Memcache, and this provides you low latency in-memory data store. And again, these are managed services. So AWS handles the underlying services for you. So underlying management, hardware setup, configuration, scaling, and everything is handled by AWS for you. So all you have to do is to use the service, whether you want to use it as a caching or we will look at it or as this thing. So what does that mean by in-memory, Redis and Memcache? So I want to highlight a little bit of the difference here and when to use this different engine. So simply, Memcache is just for simple in-memory key value, simple object store. Usually, like you want to handle session management or you want to store session. So you have a session, you have the key to the session, and you want to store it somewhere. So this is in-memory Memcache that you use. It's a simple database, and it supports simple kind of data structure, which is like string and objects. And you can multi-thread it, that's okay, but in the sharding area, you need to, the client need to handle the kind of the logic or the sharding kind of the multiplexing at the client layer. It's easy to scale because you add more storage, more data when you scale, but it's not persistent. So it's not persistent. So and it's open source. So you just look at this is not persistent. This supports simple data structure, and this is kind of simple key value, and it has horizontal kind of scaling, but you kind of have some downtime there when you are scaling as well, right? On the other hand, Redis is much more a complex, support much more advanced data structure like set, sort, hash table, and this thing, and it has high availability architecture. So it's not like so that means you can have multi-easy and you can fill over to the this thing. And then you can have sharding through online sharding. That means you still have your database online, but it can still shard. And then you support this data gaming, scripting, and so on. So if with a more complex workload, more high availability requirement and stuff, you kind of look at the Redis as an engine to support that. Right. So then I'll be quick to go through. So since you can persist, we talk about temporal like cache there is an in-memory database itself that, I mean, like if you want to use it as your primary database, you can persist the data. And this is only Redis compatible because, the Redis is an advanced one with advanced structure and as multi-easy, and then we didn't talk about the cluster. Yes, a cluster and non-cluster part. But this, you can use Redis for in-memory, which is the same requirement, but this time you are persisting your data, and your data is being stored in the in-memory. So the in-memory is becoming your primary database for this application there. So the one we move to graph database as one of the SQL database. So when do you use graph database? Before we talk about the graph database itself, okay, when to use it, you have like social feed, recommendation, fraud detection. With graph database, you are looking at connection, interconnection of the database. So the connection of the database is as important as the data itself, right? So you do search, you get your results based on the weight or the quality of the data connection, right? So the relationship, so in graph database, relationship is a first-class entity, right? In a relational database, you can have relationship, but it's just relationship telling you this one connect to this one. But in graph database, relationship itself is a first-class entity. What does that mean? That means relation can have properties. You can assign properties to relationship, and you can assign characteristics to relationship, and the relationship, And with relationship, you can traverse the graph and find out and find out the results of how one item connect to another. We call it node. We have node and edge. So node is really the kind of a person or item, and then the edge is really the relation that connects them. And those, they are all entity, first class entity. They have properties. They have characteristics, right? So you can use relational database to, go through fetch and do this and query relations. But you have to query several times. You have to query the node, you have to query the relationship, and you have to put them together. You do many queries. But with graph database, the relationship is already built for you in the graph. You just need an API. You call an API, they will present the relationship. The graph will present the relationship for you, right? And one thing I also want to mention about the graph database is that, you can query the node, you can query the relationship, but hybrid, like you purchase some product and you know somebody who has purchased the product, and then that person product has a favorite product. That kind of transversal of that graph is only built with this graph database. You can have different tables on those things, query different tables, put them together, but you do many queries and many manipulations. You can do that. The reason we want to do that is scale and cost. With database, there is always two dimensions: the cost, performance, speed. If any of them is out of whack, you look for something else, because then it's not sustainable. You can't scale, and you can reasonably run your workload with enormous amounts that you put in an enormous time that it takes. That's not where for meaningful information, it needs to come in a cost-efficient and in timely manner. So this is graph database, and usually the graph database, you use what we have here. We use Amazon Neptune. And then this is also managed service, and it provides really a reliable graph database in the cloud. So it supports these two popular kind of data graph models like Tinkerpop from Apache, and then the WCC RDF, and also the language. They support the query, support the Sparkle, and then Kremlin. And as you can see, you can query billions of relationships with milliseconds. For example, Nike has an application that their athletes, thousands and thousands and thousands of their athletes, they put them this, and then the athletes have interest, and that athletes' followers have a lot of interest. So each follower can find interest of the other follower. So this is like complex connected data and complex things, and this is the sort of thing the graph kind of is built for. You can transverse the complexity, and you find what interest of a fan of athletes has common with other interests. So you can do that, and it's done within the graph database, not in the application layer that you need to do. And it's also reliable, 6 replicas, 2 in each AZ, and then support this graph query like Gremlin and Sparkle. So it means, it's also a fully managed service that we do. And then the another thing that I want to mention here is that, sorry, I'm walking through all this, but I want to give you the foundation of this thing. Is a time series database. So what is time series database? Time series database is a database that is purposely built to handle time series data. And what is time series data? Time series data is a data which has a characteristic of, arriving in time order, and it's append only. So you have a sensor. Every second, the sensor, second, 5 seconds, whatever, every time the sensor is kind of emitting data, and then the data is coming in that order, and it's constant. And you can't change that data. It's append only. So how do you handle those data? How do you process those data? And this is what graph database kind of handles for you. And one thing about graph database is that when you are dealing with time series data, you are dealing with windowing within this period. What is the moving average? What is the window? How do I get the average within these windows? So how do I bin my data? And these are all features and characteristics that is being built in time series that you don't have to worry about it at the application layer. And then with the AWS time streams, I mean, like here you said, it's a serverless, sorry. With AWS time streams, a serverless kind of service. That means you don't have to deal with servers and configuration, and it's kind of decoupled the compute and storage and ingestion. So you can ingest as many as while you are computing, processing your data, and then you can store as much. I mean, it's serverless. So, and these, you don't compute on resources with the ingestion, you don't compute with resources with the processing, you don't compute with resources with the storage. So it's blazing fast. So like you said here, I mean, you have, it also handles time-based analytics. What is the latest? Where do you want to keep your data to handle latest kind of data, and where do you want to move your data to handle late data? The time series knows where in-memory database store and magnetic database store, and you can query both. And it can automatically, with kind of retention period, move your data from the more expensive in-memory to the less costly kind of, what do you call it, magnetic store. But you can still access those data to do your, to run your analytics, time-based analytics. And then, this is, we talked about this wide column database. Basically, what this means is that it's kind of a distributed kind of storage system, very flexible in terms of schema, and then it stores rows and column. But with the wide column is that it does, every column can have different, every row can have different column, different set of column, different percent. So, and what that gives you is the high throughput in write. So this kind of data is purposely built for, distributed data storage, but high write throughput. Because you don't have to care about the schema. You don't have to care, oh, do I have enough column for this? No, just writes and it's pretty fast. And AWS offers Keyspace as a managed service of Cassandra. So it's Cassandra compatible. The Cassandra that so, and then the rest is we manage kind of the database for you. Like you don't provision data, you don't provision it, no patching, software, hardware, you don't do anything about it. And then we have kind of a highly available, like 2-3 storage, 3 times across the different AWS zones spread around, and the encryption at rest. So in the operational and maintenance side, it's taking care of it for you. And then it provides you the cloud resources that you can scale without really thinking about it. So this is what we provide in terms of in-memory. So the last one I want to mention is about ledger use case, which is the kind of is in the kind of blockchain area. So the ledger, which call use case, is where, if you look at the financial industry, or you look at the healthcare industry, or you look at the legal industry, or even in the car industry, where records, the history of records, and records is both a regulatory thing that it must be maintained, or is critical part of the application that it must not be tampered with. This is where you use the ledger use case. Or this is where you use the ledger database. You have the journal. Every insert is immutable. Every operation delete is immutable. So it records every operation that you write, and you cannot, what do you call it? You cannot delete it. Even if you delete the database, the journal is there, and it maintains the integrity of the data by cryptography variable mechanism that you can use hash or SHA-25 to check the digest, to check the validity, the integrity of that operation or that activity. So in this case, I mean, this kind of application, you will find it in financial industry, you find it in financial banking, you find it also healthcare, where everything needs to be there and intact, and you find it in any kind of workload that you want to record, and you want to maintain the integrity of the records forever, And then you want to go back and check the integrity as well. So is this tampered with, is this cannot be tampered? And this is where the ledger use case comes to play. So I'm not going to go into details here. What you need to know is that it's immutable. The sequence of records cannot be changed, cannot be deleted or modified, and it's verifiable. So you can always go back and verify that it is what it is and it hasn't been tampered with. And the rest is kind of AWS way of managing that database for you, right? So painfully for you guys, I've just walked through all this database, try to show you when to use it, when not to use it, and what is this purposely designed for, and the characteristics of a different kind of workload that we run. But just to leave you with the kind of best practices that you think of your mind when you are dealing with database. I mean, we talked earlier on about rather than having a database or data model and trying to fit your application to fit your data model, you start to look at your application, especially the microservice. What is the characteristics of my service? How does my service handle data? How does my service store data? How does my service retrieve data? What is the access pattern I need? What is the scalability in mind that I need? And then you come to what kind of database will fit my need for that application. So the database design, the database should be used based on the design of your application, not the other way around. Not because you have the license for that database, not because this is what you have skill set for, or not because this is what is the latest. It has to be because this is what fits my application characteristics. So one of the things I will leave you to look at is that when you look at the access pattern, you look at the data types, you look at the flat versus JSON. Like when you are looking at the key value, you look at Dynamo versus document DB. Is it flat? Is it JSON? Do I need flexibility there? And also look at the scalability, volume and size of data over time, And then the modeling, you always choosing the key. We haven't talked about selecting the unique key, the cardinality, but this is one thing that you look at it like, what is the key? Do I want my data to be already stored as I would want to use it? Or do I want to start searching all the table and building the view on my way out? So it is a kind of instantiated view plus the view that you build when going out. What is your data model? And then we'll talk about the access pattern. Do I need a key value or do I need a range lookup, or full search, the indexing. And then do I need ad hoc queries? So if I need ad hoc queries, then you consider Dynamo really is not for me because Dynamo, I need to have my access patterns ready and know. Flexibility with some global secondary index, but let's not go into that. If my access pattern changes over time, Dynamo is not really my thing, because you need some fixed access pattern to use it. Your schema can change over time, no problem, but you need to look at the access pattern also. And then do I need consistency and durability? Do I need integrity? So is it like when I write, do I want to see the read with all my clients at the same time? Or I don't mind the eventual consistency, So that goes also to the scaling. What is my source of truth? You always have source of truth that we talk about initially, the primary database, and you can put cache in memory in front of it. The memory can contain most read data or most queried data there. And then those data can expire. You have TTL on that. Then you have your primary database. You have or you can have your primary database like relationally you can move. We talk about data movement, right? You can move the data elsewhere for specific transaction. You can move into S3, you can move into Redshift. So there is this still data movement within the AWS environment. Data validation and reconciliation, which relational database has really strong. You can validate the column, you can validate the row, you can check whether, you can always check before data is insert or update, whether it meets certain condition. And you can always make sure that you put some condition on the column in terms of what the type and what it must be. So you have this validation integrity with this is that what you need for a business application. And then the performance. I mean, if you want skill, infinite skill, then you are looking at kind of NoSQL kind of database. And and like Dynamo and this. What is the scale? What are you looking at now? And then the last part is data integration. You do a lot of it going forward. How do you do federated query? How do you build ETL? We have a lot of zero ETL coming, but you do a lot of it going forward in this course and data lake. These are the things that you'll be working on going forward now. So I will not go into the summary because I brought it up earlier just to walk you through. And right now I'm gonna stop here and ask any questions, or maybe there will be a lot of questions on the
So there has been a lot of questions. I think I have been able to cover most of them, but now, so there's time to ask questions. So you can either drop it in the chat and we can take them that way, and feel free to ask.
I actually have a question over here. There you demonstrated two examples or use cases. One was a real-time bidding, and one was leaderboard update. And I'm very beginner in learning these concepts, but both of them felt like really kind of like similar. Like real-time bidding, it needs to be saved and taken into account in a very short of time, and then the leaderboard update, that also takes time in a very short distance, and you need to be accurate for it. However, in both use cases, you recommended that we use two separate type of Amazon purpose built databases. Do you think like both of those use cases could be considered to have same database? Or, and my most important question is like how we can actually determine, like for one use case we would be able to select that specific type of database. Thank you.
Yeah, so thank you for the question, and I think it's a good question. So one thing you look at, forget about the database and then look at your application. What is that? You said real time and bidding, you need a kind of a fast response, low latency, right? And then you need the resource, you need to see the resource quickly, you need a low latency, and you need any computation that happen, you need to be rendered.
Yes.
So based on that application, you look at what are these at what to then and then you also said it's the same for bidding and real-time application. So then you have the same requirement. You have same requirement in terms of latency, you have same requirement in terms of throughput, and you have the same requirement in terms of access pattern, right? So this is what you need to look at, So once you are looking at that, you say, oh, to be able to meet this kind of requirement, I need some kind of, low latency in-memory kind of database to be able to meet this requirement. So that means we are looking at a single database that will handle it, because it's the same requirement that you are putting on a data store. Yeah, and then once you come to that, you also look at, oh, do I need a complex structure? Do I need like just a simple key value or object to be fetching this data, or do I need some calculation, ranking, sorting in terms of what do you call it? In terms of who comes first, in terms of who goes, in terms of the bidding, right? Somebody will bid more and this, and so I need a little bit of complex structure, advanced structure here, which is sorting to sort the data based on the number of the build, the number of the bid. Then you are looking at Redis Memcache, because that is a database that can support advanced data structure, can support, has a sorting ranking for you. And it's the same for bidding and the real time that you're talking about.
Yes, thank you.
So always spend your time on your application. Always spend, what does my application need? And then you move to the when you finish your functional requirement, then you move to the non-functional requirement. What is the scalability? What is the performance? What is the high availability nature that we need? Then after doing all these things, by the time you finish, you can see clearly where you lie. in terms of which purpose-fit database will support that application for that workload.
Any other questions? There's nothing in the chat at the moment. You can either drop it in the chat or unmute yourself, and you can also ask in Finnish if you want to ask in Finnish. So.
Yeah, and also you can reach out to us anytime. Yeah.
Hi, I have a follow-up question.
Yeah.
Like in practice, like if I'm looking at my app and I just try to set it up at the initial stage, in practice, what is sort of the most common scenario in a company? Is it like, okay, then I will have select the most closest to database, then I just have a playground and try both and then see the performance and compare.
Yeah, so I'll tell you some of the companies, they just do what they kind of some of the companies, they just use the database they are familiar with, right? Like, hey, we know SQL, we know this, and so let's use SQL. Or some of the companies, they just use the license we have, but this is not what we want you to do, right? What we want you to do is that, I mean, you are building your application, right? So look at your application. What would my application, and usually we talk about microservices. So you have different services. Let's say you are building some services and this. What you need to do is that, how do I said earlier on the access pattern of my application. How do I want to store the data? I want to store it as document. I want to store it as kind of in tables. And then what is the kind of business rules also? Do we allow this and that? So if you look at, I will share the document with you, look at the best practices, go through them and go to what application need. In terms of trying it out, it depends on your company policy. If you come to the database that you want to try out, but the nice thing about the cloud is that you can spin and decommission any managed database as you like, So for me, I'll quickly you go to this serverless kind of, since you are trying out, you can take Aurora serverless if it is relational database that you think your application will support by doing those analysis, or you can take Dynamo, Dynamo on-demand capacity. You can just try them because those things you pay as you go, you know what I mean? And if you don't run anything, you don't pay anything, right? So in that sense, you are looking at the cost and you are trying to do your testing. And then most of our database, we have what do you call monitoring. And then you have the other part that is linked with CloudWatch, that you can see all the different kind of metrics of the database, like what are the different events, you can even check the processing, the load, and these things. If you want to go a little bit further, you can look at this CloudWatch event, or the database have this monitoring part that you can click and you can see how they are performing. But to really see how things are performing, you need to kind of test it on a production scale, because there are some things that performs well when you have like one or two clients kind of requesting for it. And then it start to mess up when you have like thousands and millions of clients. That's why we always recommend managed database, because in terms of that traffic, the managed database can handle that kind of performance and scalability for you. But for you, really, really look at your application and look at what you need. How your application store data, how it store the data, what is the access pattern, and what is the requirement of your application? Is your query always changing? Do you have ad hoc query, or is your schema changing? Or do you know beforehand, or you don't know beforehand? These are all important things that you need to put and then try. Only then look at, which database will be perfect fit for this. And then you select the database. And then with cloud, you can always, do it again and again. If you select database, you can just decommission it and select new one as you are experimenting. I hope I answered your question correctly. Did I answer your question?
Yes, thank you very much.
You're welcome.
There's a couple of questions in the chat. The one
Yes.
that I already answered a bit, but feel free to share a bit more. So there was a question from Anni. Would it be accurate to say there's not necessarily only one correct choice of database for every use case? And what I mentioned here is that I would say that yes, it's possible that you could do the same thing with multiple different tools, with multiple different data services, but sometimes there might be financial restrictions. Let's say if you would decide to take like a hugely expensive disk or service, even though it might be the best, but sometimes you have to look at the cost side. But how do you feel, Adamu?
Yeah. I think you're absolutely right. And the question is also absolutely right in terms of when you are building within an enterprise or corporation, you also have the rules on which you abide on, right? And so sometimes, I mean, like for example, Dynamo and DocumentDB, and you are using maybe you want to use a document, but it's a simple document, and you have you don't have really nested kind of a data structure in your document, right? And then you look at you need scale and you need this, and so maybe Dynamo will be even best fit there because you can handle a little bit of simple document, but you don't have this flexible query, advanced kind of query on different attributes. You don't even have to use DocumentDB at that point in time because the thing is that does this meet my requirement and does it meet other requirements like performance, scalability, and thing, right? And then the second thing is that always think about scale, always think about performance. When we say scale, we don't mean that you scale and then your performance will degrade. You know, we are talking about the speed on which you receive one item in your database should be the same as 1 trillion items in your database. So which kind of database can handle this thing? So when you go through it, like everything else, you have to do trade-off at the end, you know, like what Ursula said, whether your customer, your company has some rules and these things. But always when you do trade-off, even if you don't get the ideal one you need, you get something close to what you need. So the trade-off is always there. And the thing you have to look at is that all these things relational database can do. Why? It's been done before. But with database, you are looking at 2 dimensions, cost, speed, and performance. You know, I can query a data. If it takes 2 days to receive it, I will still receive it. But does it meet the purpose? Is it performance enough? Is it fast? And then I can add more money and cost for compute to put together all this table to generate one view instead of picking it at one request from Dynamo. I mean, but is there a reason not to do that? Yes, it's too costly. Is there a reason not to do it? It's too kind of inefficient. You know what I mean? So then you look at what else can give you that 2 dimension, this cost and speed and performance. And when you look at Dynamo, the view is already there. You just want to API, you fetch the document. Yeah, that's a speed and the cost aspect of it. But do I have flexible kind of ad hoc query? If I don't know all my queries beforehand, then Dynamo might not be the perfect one for me. Because with Dynamo, I need to understand my access pattern before I start building my data model. If I don't, then it's not a good one for me. Then this is how you go through. There is no perfect answer like if I meet this, and this. But you need to go through it. And then when you are doing the trade-off, you know what you are doing trade-off with. You know? So did I answer the question or did I add anything to the response?
I think you did. I think you did. We have a couple of questions in the chat. One was I think I answered it, but let me share a bit more. So there was a question from Riikka that in what level do you have to understand these different products or services for the exam? And what I said is that for data engineering, you have to understand the beginner concepts and also intermediate level. So typical question that could happen in an exam is that the customer need is something, let's say for speed, for let's say like acidity, for example, could be one thing that's mentioned in the exam. So basically saying that the customer needs a database that supports acidity. That kind of targets you towards the right answer. So they won't be like hugely difficult, but I would say intermediate is kind of the level that you can expect. There was one very specific
So
question.
I also, Ursula, let me add
Yep.
also, this is data engineering is kind of fundamental intermediate. So always pay attention to when to use what. I mean, what service to use. I mean, you don't, like when we talk about, we just talk about in-memory database. You know, we have two of them. We have Memcache and we have Redis. So you should know when to use what is the difference, right? Basically, when to use Redis, when to use Memcache, right? These kind of things. When do I use Memcache? When I have simple just key value kind of session store, and then when I have advanced, then I use. So just these differences and what you use, I think that will be something that you should also take into account when going through this material, right, Ursula?
Yeah. And then there was a very specific question, and then I have one product question here. Specific question was, I think it was a part for the slide deck. There was a mention of schema. So could you share what schema means?
Yeah. So schema is how, so let's put it this way, it's your database structure, right? So take a table, right? In the table, you have rows, you have columns, right? And then schema is how do you want your table to look like? What are the columns you want to add, and what are the data types you want to accept in that columns? So that when I define my schema and somebody takes my schema, the person can build the table anywhere, anyhow. So it's like a DDL kind of thing. So that is, in simple form, schema is how you define the structure of your table, the columns, what the data types they can contain, and maybe the table name or whatever. But this is the schema. So it's like a template. Yeah, let me put it, it's like a template for your table. How will my table look like? My table will have a name column, which is a string. My table will have an age column, which is what? Integer. My table will have a date column, birth of date. Is it date of birth, which is a date data type. So, and then I define this template and I call it a schema. And then the table, you can use that to build the template to build any table of that schema. Did
I think you did. And I mean, of course, there are always, when you have different database environments, so how the schema, like for query purposes, correlates. If you look at, like, let's say Oracle databases, you see that user account and schema name always correlate in ways of, let's say, my username is Ursula, so my schema name is also Ursula. So if I would query a schema, data structures, the logical structures, to be precise, I would have that schema name if I'm querying outside from that schema. So it is a logical structure, and it behaves a bit differently depending on which database you have. Then we have a really cool question. I think this is a really important question about, let's say that if you look at long-term companies that have like tens and tens, like decades of data, and they might have like a legacy relational databases. And let's say that legacy database doesn't fully fulfill the criteria of what they would need, like the speed, performance, and such. Do you see often that you transition old systems to new platforms? So I think the question is about kind of the differences of lift and shifting and re-architecting. And is it usually how difficult to move like full databases or just parts of this? So I think that's a really valid question.
Yeah. So this kind of question also talks about migration in general, you know. So before we do migration, we always assess your environment. You know, one of the things maybe you didn't mention, like the interdependencies. You know what I mean? So if you have a legacy system, once you go into that system, you realize there is a whole lot of interdependency, and some of them are hard coded. You know what I mean? So first you go in and assess. We call it assessment phase. There are agents and things that run into all your database and check the dependency of the networking dependency, the dependency of the application. After that, you always try to take the lowest or the hanging fruit, the hanging fruit, and then this is what you move to the cloud first, This is what you move to the cloud first. And if it's a relational database or if it's any other database, what we recommend is a lift and shift. So lift and shift, you are not doing anything. You are just taking, for example, your box and put it on top of AWS, right? So for lack of better word, I use a box, right? So you take a box and put it in the AWS. So when it's in the cloud, you are using the same skill set, the same API, the same thing. It's in the cloud. Now you get the benefit of the managed service underneath it, but it's now that you look into application, what do I need to separate? What do I need to move? So then you do it piecewise, because to be honest, there are some that you cannot do anything about it. You can come to some application that everything is being hard coded and everything has strong dependence that you cannot do anything about that specific portion. But there are a lot of things you can do around those things, and this is what you do gradually. Gradual. And that specific portion probably might go its lifetime. The lifetime will pass or not, but you can still do hybrid distance and still use the leverage that portion that you may never be able to modernize it, So I would say do the assessment, look for the low-hanging fruit, and then kind of gradually move those into a managed service or into leveraging cloud native kind of database service for those kind of services. Did
I think you did, and I think like kind of chime in there, like what would be, this is by no means the only case of hard coded, but what we sometimes see, let's say somebody has been developing an application that has a lot of code in the database. So let's say like procedural code that is in the current relational environment, and actually bumped into one of these environments just lately. And we looked at the code, and it's very specific to a specific relational product. They had 25 million rows of code. So then you have to kind of calculate, like, we can transfer that and we can re-architect that, but it would mean changes to the code and the approach. And then you have to kind of weigh the balance of, it might make sense, it might make it like tremendously faster, but that 25 million lines of code, if we need it, then we need to also see how we transfer that. So those things, it might be just a time and money question. Can you at that moment do that, or should you lift and shift and then decide how to modernize and re-architect? I think that is the end of the questions, and you can still ask. Let me share my screen for a bit, and I will share some things. So like mentioned, we are trying something new, and we are trying like how would if we combine also a bit of the immersion day side of how do you get access to the practice accounts. There has been fantastic questions along the session today, and I will share you a bit more links than I was planning to at first. So couple of practical things. So we have prepared practice accounts for you. If you know that you cannot practice in the upcoming 72 hours, please don't take account, because that means that then it takes account away from the pool, and if it's not used, it's kind of like leave it for those that might still want to do the practices. If you have time, you have 72 hours once I click the start for the environment. So I will click that once the session ends, so then it will be available. I will drop now links to the chat, so you won't have to copy them from and we will share them also in the Slack. So let me try to find the chat. There is it. So now there will be a lot of links in the chat. So the first links will be the ones that handle this 72 hours of accounts. So there's a link for the getting your own account, so ordering your one-time password for your email. And the second one is actually the workshop. So what you see on my screen right now, Modern Data Architecture Immersion Day, you can do that, or you can decide to do, let's say, your practitioner exercises. You can do your own project for that 72 hours. After 72 hours, the accounts will be cleared and they will be basically restored back to normal. So you can't access the account after the 72 hours. There was a lot of questions of what about if I would like to have my own account, or what about if I would like to have another immersion day? There's also public generic immersion days happening in the Europe North. They are very specific usually for a topic. There's also public global immersion days that are happening. So that is the link to the calendar that you can see in the chat. And then there was a question, what about if I want to have my own account? And you can have your free tier account, which means that you can decide to use just services that don't incur a fee. And that is laid out in the links that I dropped in the chat. That's the free tier and free tier frequently asked questions. There's also video beneath that showcases what that means. It's actually recorded by one of the trainers that you have actually met already before. So Praveen has been kind enough to do a free tier recording. And that would be the way. Now the question is, how do I know I'm just using the free tier services? How do I keep it inside the free tier services? Couple of things. Once you set up your free tier, it will ask for a credit card number. And once you give it credit card number, let's say that you would deploy a lot of services, you wouldn't stop them, or you wouldn't actually retire any of the services, it can incur a fee. And let's say that if you're a student, it won't be fun if you get €1,000 fee for something that you forgot to stop. So one thing that I've seen that people are using is that they use also like prepaid credit cards. So basically putting a limit of like €20 on a prepaid credit card. And once it stops, it stops. So then you can't incur a bigger fee. Other way is doing by a budget. So budgets meaning that you can have alarms going off, but the budget itself will not stop anything. It just tells you if it's going over the number or the limit. So be very mindful. Also, now that you're setting up your own accounts, couple of things to know. This workshop is deployed in EU. So it's basically the region is Ireland. So if you look at the list of regions that you have, you should always choose Ireland for these practices. And all the services that you would need also for the practitioner are available in that region. So if you're getting an error that you can do something, check in which region you're in. So that's important. Sanna, if it's possible, you could also, once we stop this session, you could also share the links in Slack. So there would be that available. But I know that there's a change happening, that there will be a new Slack. So we are migrating away from the old Slack environment. So maybe sharing that Slack invite might be a good idea. And
yeah, I can do that.
Perfect, thank you. And a couple of things. So the calendar will be available on Mimmit Koodaa site. So there will be one source of truth. So there will be the link of mimmitkoodaa.fi/Amazon. They will see all the upcoming sessions. If you see that there's a session that you cannot attend, there will be recordings on YouTube. So you will get access to those also after the event. And yeah, I think that is pretty much it. So also, if you wanna network with us, feel free to do so. So happy to always network on LinkedIn. Please do ask questions, support when you need it. Actually, there's one question which is there an additional benefit of student AWS account via Educate over the free tier? I don't necessarily know the student account that well, but my assumption is that there's most likely more kind of free services for the students who are enrolled in, let's say, educational institute. But Adamu, do you have insights of what's the difference other than?
I don't, unfortunately, I don't have that information. Yeah.
Yeah, we can check. So actually,
Yeah.
we can also check that if there's specifically something. So if you're in an educational institute as a student, I would assume that then you get a bit more access, but we can check what the difference is. But I think feel free to ask questions still. So we will be here for a bit more, and I think go ahead.
Hi, I actually have one question. You asked about, you told us about the usage of the free tier, and then like we need to add like maybe our credit cards or some prepaid credit cards. Can we still like stop it after we have tried out with the free tier and then we have cleaned up our all or everything that we have worked on? Should that the cost would still incur there?
So if you always stop the services that you have deployed, let's say that you would deploy, so any of the services that are included in free tier, let's say an EC2 instance, and you will use services that are included in the listing of the free tier on the pages that we linked, that won't incur a cost. But let's say you would deploy something that is outside the free tier and you wouldn't stop it, that would incur a cost. And what we sometimes see is that students might not look at the list that much, and then they deploy something that has a higher cost, and then there's a panic that then there's a cost on their credit card. So that is one of the reasons I've said, like, even though if you use a prepaid credit card, it's a hard stop when it stops billing, but then you know that you can't go over that limit, so then it's cut off. So that way, that might be one way of doing it. Or then you will use like these immersion day accounts that we provide for you, and then like 3 days, and then the accounts are gone, so they are cleared, and you are not putting your own credit card against them.
Okay, so I think this is better to use the 72 hours one to try out the things. Okay, yeah, I would do that. Thanks for clearing this thing up. Thank you.
Thank you. Thank you. Any other questions? Yeah, there's a question. Are there some exercises you are supposed to do with the practice account? On the link list, when you look at so there's the join access code link. That's the link that gives you the account. So basically you get a one-time password for your account. And once you log on, you will log on to a portal that shows you also the exercises. I have also attached the link, which is the catalog link. So this is basically hang on, if I can copy it, I will. No, it's not copying it. So the second link on my list is the catalog workshop link that shows you a data architecture immersion day. You don't necessarily have to do that, so it's not mandatory that you absolutely do that, but it's one that actually explores many of the topics that we will be talking about along the journey. So you can decide also to do your own exercises, but remember that it is in that region. So Ireland being the region that has the services enabled, so that's good to keep in mind.
Ursula, I'm not sure if this is with my Slack, but I already joined in the Mimmit Koodaa X AWS Slack channel. There is this thing called 3 days left in trial. I'm not sure if it is from me or this is from the organization. There
I
is this thing.
think it's probably Sanna knows that the best. So
Yeah, because I am now like in other channels, but I never see those in there. But only with Mimit Kuda and AWS, there is this information always coming like 3 days 3 days left in trial.
it could be that it's like a new account that is being set up. So Sanna,
Yeah,
yeah.
we cannot change that. It's the Slack who wants to inform us that there is only 3 days this free trial. So you need you need to do anything. We are responsible of that. So
Okay.
no worries.
All right. Thank you.
Thank you.
All right, I think that is pretty much for the questions. So hey, thank you so much for spending the time with us, and we will see you in the next one. Practical things. I just started the exercise environment. So now that you're clicking on the link joining the event, you will have access to the environments, and starting from now, it will be 72 hours available. Thank you so much.
Thank you. Thank you. Yeah.